Most people believe space is completely silent. But it's not. If you could hear plasma waves, you'd listen to the roaring storms of Jupiter, the heartbeat of the sun, and the echoes of distant supernovae. Sound doesn't travel through the vacuum like it does on Earth, but the universe hums with electromagnetic vibrations. Space speaks. We just didn't know how to listen. Until now. A black hole could erase you from history. When we think about black holes, most of us imagine a cosmic vacuum cleaner, a terrifying monster that swallows everything in sight. But the reality is far more complex and deeply unsettling. Black holes do more than just consume matter. They challenge the very foundation of how we understand existence itself. Let's start with the basics. A black hole forms when a massive star collapses under its own gravity, compressing its mass into a point of infinite density called a singularity. Surrounding this singularity is the event horizon, an invisible boundary beyond which nothing, not even light, can escape. Crossing this boundary means losing any hope of return. Now, here's where it gets truly strange. According to Einstein's theory of general relativity, once you cross the event horizon, you are doomed to be crushed into the singularity. But quantum mechanics, the physics of the very small, tells a different story. One of the fundamental laws in physics is that information can never be destroyed. This is known as the conservation of information, and it's a principle as sacred as the laws of thermodynamics. But black holes appear to break this law. In the 1970s, Stephen Hawking shocked the scientific world by showing that black holes aren't entirely black. Instead, they emit a faint glow, now called Hawking radiation. Over unimaginably long timescales, this radiation causes black holes to lose mass and eventually evaporate completely. Here's the paradox. If the black hole disappears, what happens to the information about everything it ever swallowed? If the information is truly lost, then quantum mechanics is wrong. But if the information somehow survives, it must escape the black hole, but that contradicts everything we know about the event horizon. This contradiction is known as the black hole information paradox, a puzzle that has baffled physicists for decades and remains unresolved. Why does this matter to you? Because, in theory, if you were to fall into a black hole, the fate that awaits you isn't just physical destruction. It's the erasure of your very existence from the cosmic ledger. The details of your body, your thoughts, your life, the quantum information that defines you could be lost forever, leaving no trace that you were ever here. Some scientists suggest that information might be encoded on the event horizon itself, a concept called the holographic principle. Imagine the event horizon as a kind of cosmic hard drive that stores the information in a two-dimensional form, much like a hologram projects a three-dimensional image from a flat surface. This idea hints that our three-dimensional universe might itself be a holographic projection of information stored elsewhere, but that's still speculative. Other theories propose that information escapes gradually, carried away by Hawking radiation, in a scrambled form that's practically impossible to decode. And yet others speculate that black holes might connect to other universes through wormholes or white holes, potentially transferring information elsewhere in ways we don't yet understand. Despite decades of research, the black hole information paradox remains one of the greatest unsolved mysteries in physics. It threatens to overturn our understanding of reality, forcing us to rethink the nature of space, time, and even existence itself. So, if you ever find yourself on a one-way trip into a black hole, remember this: you might not just be destroyed. You might be erased not only from the present but from all memory and history. The universe could rewrite its own story as if you never existed. And that is a secret that makes black holes far more terrifying than any sci-fi monster. Now, let me tell you a secret about what you're really made of. Not just ordinary stuff, but something truly cosmic. You're made of stardust, but also of explosions. It sounds poetic, and it is, but behind that poetry hides a violent and fascinating story billions of years in the making. Every atom in your body, from the calcium in your bones to the iron coursing through your veins, was born inside stars. Not just any stars, but massive ones that lived fast and died in spectacular fashion. Stars are like cosmic forges. Deep inside their cores, extreme pressure and heat smash lighter elements like hydrogen and helium together, fusing them into heavier ones: carbon, oxygen, nitrogen, the very building blocks of life. This process, known as nuclear fusion, powers the star for millions or even billions of years. But here's the explosive twist. When a massive star runs out of fuel, it can no longer hold back gravity's relentless crush. Its core collapses catastrophically, and the star detonates in a supernova, one of the most energetic explosions in the universe. In that moment, elements heavier than iron, like gold, uranium, and platinum, are forged in a flash of incredible heat and pressure. These supernova explosions scatter those elements across the galaxy at thousands of kilometers per second, seeding space with the raw materials for new stars, planets, and eventually life. Without these cosmic blasts, Earth wouldn't have the essential ingredients to support us. No oxygen to breathe, no iron in our blood, no calcium in our bones. So, in a very real sense, you are the product of ancient stellar violence, the remnants of stars that exploded billions of years ago. Your very existence depends on those titanic cosmic fireworks. Next time you look at your hands or take a breath, remember, the atoms inside you once burned inside a star, then flew through space on the back of a cataclysmic explosion. You are not just made of stardust. You are the living legacy of the universe's most powerful forces, born of light, fire, and destruction. Now, here's a mind-bending secret about the universe itself. What if everything we see, everything we experience in space, is actually a hologram? It sounds like science fiction, but this idea comes from some of the brightest minds in physics, and it challenges everything we think we know about reality. The holographic principle suggests that all the information contained within a volume of space can be described by information encoded on the boundary, like a cosmic skin surrounding that space. Imagine a hologram on your credit card, a flat surface that somehow creates a three-dimensional image. Similarly, our entire 3D universe might be a projection from a 2D surface at the edge of the cosmos. This idea first emerged from attempts to solve the black hole information paradox. Physicists realized that the physics inside a black hole could be fully described by information stored on its surface, the event horizon. From this insight, they speculated that this principle might apply to the entire universe. In practical terms, this means everything we perceive, the stars, planets, even ourselves, might be encoded on a distant boundary. Our sense of depth and volume could be a kind of cosmic illusion. But what does that mean for us? If space is a hologram, it challenges the very nature of reality. What feels solid and real could be a projection of information stored somewhere else. It pushes the limits of physics, blending quantum mechanics with gravity in ways we don't yet fully understand. Experiments are underway to detect holographic noise, subtle fluctuations in space, time that could hint at this hidden structure. Though the evidence isn't definitive yet, the idea opens a door to a radically new understanding of the universe. So next time you gaze into the night sky, consider this. The vast cosmos might not be the endless three-dimensional space you imagine. It might be a giant, shimmering hologram, a beautiful and mysterious illusion, written in the language of information. Let me take you deeper into one of the most mind-bending and unsettling truths of our universe: time. That relentless river we all swim in can actually come to a complete stop. And what's more, somewhere far out in the cosmic ocean, it already has. We tend to think of time as an absolute constant, the unstoppable march of seconds, minutes, and hours. But since Einstein revolutionized physics with his theory of relativity, we know that time is far from fixed. It is a flexible dimension, intertwined with space itself in what we call space-time, capable of bending, stretching, and warping depending on gravity and velocity. Consider the extreme environment near a black hole, a region where gravity becomes so intense that it distorts the fabric of space-time beyond our wildest intuitions. If you were to watch an astronaut falling toward the event horizon, the boundary of no return, you would see their movements slow dramatically, stretching out like a slow-motion scene in a movie. To you, time for them appears to slow, almost grinding to a halt, while for the astronaut themselves, time ticks normally at least until they cross the horizon. This difference in perception is known as gravitational time dilation. The closer you get to a massive object, the slower time flows relative to someone farther away. At the event horizon itself, time would appear to stop completely from the outside observer's view, freezing the falling astronaut forever in that moment. But black holes aren't the only place where time's flow warps. Einstein's special relativity shows that as you move faster approaching the speed of light, time slows down relative to a stationary observer. If it were possible to travel at light speed, time would effectively stop for you. Though impossible for objects with mass, this tells us time is not universal, but deeply relative. Now imagine, somewhere out there in the universe, objects or regions caught in such extreme conditions, intense gravity, immense velocity, or exotic quantum states where time has ceased to progress. In a sense, parts of the cosmos could be frozen in an eternal moment, untouched by the relentless forward push of time we experience. Physicists are also exploring exotic phenomena called time crystals, states of matter that could loop or freeze time in unusual ways. These are not science fiction but cutting-edge research, revealing how time might behave differently at the quantum level. This has profound implications. If time can stop even somewhere far away, it challenges our fundamental understanding of reality. It means the universe isn't a simple linear story but a complex tapestry where the flow of time can pause, distort, or even rewind in ways we are just beginning to grasp. So when you glance at a clock or watch a sunset, remember that steady flow you take for granted is just a small part of a much stranger cosmic truth. Somewhere, time has stopped, and the universe waits, holding secrets beyond the limits of our experience. Now, buckle up, because I'm about to reveal one of the most extreme and surreal secrets of the cosmos. There are planets out there where it literally rains glass. Not just a drizzle, but shards of glass raining down from the sky. This isn't science fiction or fantasy. Thanks to advances in space telescopes and exoplanet discoveries, astronomers have found worlds so wildly different from Earth that their weather defies imagination. Take, for example, a class of planets called hot Jupiters, massive gas giants, orbiting perilously close to their stars. On some of these infernal worlds, temperatures soar to thousands of degrees Celsius. Under these blistering conditions, intense winds race across the planet at thousands of kilometers per hour. The scorching heat vaporizes minerals in the atmosphere, including silicates, the very stuff that makes up glass here on Earth. These silicate vapors condense into tiny glass droplets high in the atmosphere. But the story gets even more terrifying. Fierce winds sweep those glass droplets into razor-sharp shards, which then rain down violently on the planet's surface. Imagine standing in a storm where instead of water, shards of glass pummel the ground at hypersonic speeds, an utterly alien and deadly weather phenomenon. One of the most famous examples is the exoplanet HD 189,733, about 64 light-years away. Scientists studying its atmosphere detected signs of silicate clouds and violent weather patterns. The winds there can reach up to 70 kilometers per hour, fast enough to slice through metal. The rain, glass, cutting across the planet like a lethal storm. This kind of weather reveals just how bizarre and hostile other worlds can be, shattering our Earth-centric ideas of climate and conditions. It also reminds us how lucky we are to live on a planet with water, rain, and breathable air, instead of storms of deadly glass. So, next time you're caught in a rain shower, be grateful it's just water falling from the sky. Somewhere out there in the vastness of space, glass storms rage, a dazzling, deadly spectacle born from the wildest extremes of physics. Now, let's dive deep into one of the most profound and unsettling mysteries of existence, the fact that the universe, according to everything we understand about physics, quite literally shouldn't exist. Yet, here we are, inhabiting a vast cosmos full of stars, galaxies, and life. At the heart of this paradox is the balance between matter and antimatter. Right after the Big Bang, the universe was a hot, dense soup of particles and antiparticles created in nearly equal amounts. Matter and antimatter are perfect opposites when they meet. They annihilate each other, converting into pure energy. So, logically, the universe should have self-destructed almost instantly, leaving behind nothing but radiation. But something tipped the scales. Somehow, a tiny fraction of matter survived, about 1 part in a billion, enough to form everything we see today: planets, stars, and even us. This tiny imbalance is called baryon asymmetry, and understanding why it exists is one of the biggest unsolved problems in modern physics. Physicists have proposed several theories, such as CP violation, where the laws of physics treat matter and antimatter slightly differently. Experiments with particle accelerators, like those at CERN, are trying to measure these differences, but so far, the mystery remains. Next, there's the incredibly precise tuning of the fundamental constants of nature. Forces like gravity, electromagnetism, and the strong and weak nuclear forces have values so exact that even the smallest deviation by a fraction of a percent would prevent atoms from forming, stars from igniting, or the universe from expanding in a way that supports life. Then, the biggest puzzle of all: dark energy. This mysterious force pushes the universe to expand at an accelerating rate. Its measured strength is astonishingly small, but perfectly balanced. If dark energy were even a tiny bit stronger, the universe would have expanded too fast for galaxies and stars to form. If it were weaker, gravity would have pulled everything back together, causing a cosmic collapse. All this fine-tuning has led to speculative but fascinating ideas. The multiverse theory suggests that our universe is just one of many, possibly infinite universes with different physical laws. We just happen to live in the rare one where the conditions are just right for existence. A cosmic lottery jackpot. From the Big Bang's chaotic birth to the delicate balance of forces holding everything together, the universe's existence is a remarkable coincidence, a cosmic miracle in which the tiniest asymmetry and perfect tuning have allowed everything to unfold. In a way, this mystery invites us to wonder about our place in the cosmos, whether it's fate, chance, or something deeper at work. The universe shouldn't exist, but it does. And that means the very fact of our existence is a profound and astonishing miracle written in the language of physics. Now, let's dive into a truly cosmic mind-bender. The possibility that aliens might be watching us right now, but only as we were long ago, from our distant past. This strange idea comes down to one fundamental fact about our universe. Nothing can travel faster than light. Light speed is the ultimate speed limit. Because of that, when we look out into space, we're not just looking at distant objects, we're looking back in time. For example, the light from our own sun takes about 8 minutes to reach Earth. So when you see sunlight, you're literally seeing the sun as it was 8 minutes ago. If you look at the nearest star system, Alpha Centauri, 4.3 light-years away, you see it as it was over 4 years ago. And the farther we look, the deeper into the past we see. Now, Imagine an alien civilization 0 light years away from us. If they had a super powerful telescope pointed at Earth right now, they wouldn't see today's world. They'd be seeing Earth as it was a millennium ago, in the early Middle Ages, before the Renaissance, before modern technology. If the aliens are 65 million light years away, the distance to the famous Whirlpool galaxy, they would be witnessing the time of the dinosaurs on Earth, the Mesozoic era. To them, our planet is frozen in the past, long before humans even existed. This cosmic time lag means any signals, observations, or communications between us and extraterrestrials are delayed by vast stretches of time. The now for them is not our now, but some ancient moment in Earth's history. Scientists have even considered the SETI paradox, the search for extraterrestrial intelligence, with this in mind. Even if alien civilizations are out there sending signals, it might take thousands or millions of years for their messages to reach us. And by the time we respond, they could be long gone or evolved into something unrecognizable. Let's get more concrete. In 1974, humans sent the Arecibo message, a radio signal aimed at the globular star cluster MI13, 0 light years away. If any civilization is there, they won't receive or respond to that message for 0 years. By the time we get a reply, Earth might look very different or might no longer exist. There's also the idea that advanced alien observers could be watching us through cosmic time capsules, maybe through signals sent millions of years ago, or using technologies that bend or circumvent the speed of light, like hypothetical wormholes or quantum entanglement. While speculative, these concepts show how our understanding of time and observation is still limited. So, if extraterrestrials are indeed watching, they're watching a historical replay of Earth's story, a live broadcast of dinosaurs, ancient civilizations, or the birth of life itself. We could be cosmic actors on a stage whose audience is always a few thousand, million, or billion years behind. It's a humbling, almost poetic thought. The universe is not only vast in space but also in time. And when it comes to alien observation, the past is never really gone, it's just being viewed from unimaginable distances. All right, get ready for a cosmic thriller, because the universe might be hiding a rogue planet hurtling toward us right now, and we wouldn't even know it until it's too late. Rogue planets are mysterious wanderers, massive worlds that drift through space without orbiting any star. They're like cosmic loners, cast out from their original solar systems by gravitational chaos, or maybe even formed alone in the darkness of space. Unlike planets in neat orbits, rogue planets roam the galaxy silently, invisible in the dark. Now, here's the chilling part. Because they don't reflect sunlight the way planets orbiting stars do, rogue planets are almost impossible to detect with traditional telescopes. They don't glow, they don't shine. They're cold, dark, and stealthy, literally hiding in the cosmic shadows. Imagine one of these wandering giants, maybe as big as Jupiter or even larger, barreling through interstellar space on a collision course with our solar system. Because it's not orbiting a star, it wouldn't show up in the usual sky surveys that track planets and asteroids. It could be coming right at us, and we wouldn't spot it until it was dangerously close. Scientists estimate there could be billions of rogue planets in our Milky Way alone. Some could even have moons or atmospheres, potentially harboring strange forms of life in underground oceans warmed by internal heat. But for us here on Earth, a rogue planet entering our neighborhood could wreak havoc its gravity, disrupting the orbits of planets, sending asteroids hurtling toward Earth, or even causing catastrophic climate shifts. One famous candidate was a hypothetical Planet X, or Nemesis, a rogue star or planet theorized to periodically disturb the Oort cloud, sending comets toward the inner solar system. While no direct evidence for Nemesis exists, the idea highlights the danger lurking in the dark. Modern infrared telescopes, like NASA's WISE mission, scan the sky for faint heat signatures that rogue planets might emit, But our cosmic backyard is vast, and some objects could slip through undetected. So, the terrifying truth is this: a rogue planet could be on its way toward us right now, drifting in silence, invisible in the cosmic night. We might only spot it when its gravitational pull starts to disturb known planets, or when it's too close to avoid disaster. It's like having a cosmic stranger knocking at the door, but the doorbell is broken, and we're blissfully unaware. Now, prepare yourself for one of the most dramatic and inevitable events in our solar system's future. The Sun, our life-giving star, will one day swell to monstrous proportions and swallow the Earth whole. This isn't science fiction, it's astrophysics in action, a cosmic truth that's both terrifying and fascinating. Right now, the Sun is a stable star, about 4.6 billion years old, sitting comfortably in its middle age, what astronomers call the main sequence. It's quietly fusing hydrogen into helium at its core, producing the light and warmth that make life possible here on Earth. But stars are like ticking time bombs with fuel tanks that eventually run dry. In roughly 5 billion years, the Sun will exhaust the hydrogen in its core. Without that steady hydrogen fusion, the core will start to collapse under gravity, heating up and igniting the fusion of helium into heavier elements. Meanwhile, the outer layers will expand dramatically. The Sun will balloon into a red giant, growing to about 100 to 250 times its current size. Imagine the Sun engulfing the orbits of Mercury and Venus, and then inching closer to Earth. It's expected that the fiery Sun will literally swallow our planet, reducing it to ashes. But this final fate isn't a sudden event. It will be preceded by a long, slow agony. As the Sun grows brighter and hotter over the next billion years, Earth's temperature will rise dramatically. Oceans will boil away, the atmosphere will be stripped by fierce solar winds, and the surface will crack and melt. Life, as we know it, will be extinguished long before the fiery embrace. Some astronomers propose a slim chance that Earth might survive. By spiraling outward, the Sun will lose mass as it sheds its outer layers, weakening its gravitational grip. This mass loss could push Earth's orbit farther out, maybe just enough to escape being swallowed. But even if Earth dodges the flames, it will be a scorched, lifeless rock, stripped of atmosphere and water, orbiting a swollen, dying star. As the red giant phase ends, the Sun will shed its outer layers, creating a glowing shell of gas called a planetary nebula, a spectacular but deadly cloud of stellar debris. At the center will remain the Sun's core, a white dwarf, an Earth-sized, incredibly dense ember of carbon and oxygen, slowly cooling over billions of years. But why should this matter to us today? Understanding the Sun's death gives us a glimpse into the future not only of Earth, but of planetary systems everywhere. It reminds us how fragile life is in the grand cosmic timeline, and fuels our quest to explore and maybe even colonize new worlds before this inevitable fate. So, the Sun that once gave us light and warmth will, in the end, be the fiery executioner of Earth. A chilling reminder that in the vast, uncaring universe, even the brightest stars burn out, and everything they nurture must eventually face its end. All right, let's jump into one of the universe's biggest mind-benders, infinity. Strap in, because your brain is about to get officially overwhelmed. Infinity is one of those concepts that sounds simple but absolutely wrecks our intuition. We toss around the word all the time: infinite space, infinite possibilities, infinite stars, but can we truly grasp what infinity means? Spoiler: nope, our brains just aren't wired for it. First, there's the idea that the universe itself might be infinite, stretching endlessly in every direction with no edge or boundary. If that's true, then somewhere out there, every possible arrangement of matter exists, including copies of you having this exact conversation. Weird, right? Mathematicians have also shown there isn't just one kind of infinity. There's countable infinity, like the set of whole numbers 1, 2, 3, and so on, endlessly. Then there's uncountable infinity, like the points on a line, which is a much, much bigger kind of infinite. Your brain? It can't even begin to hold these different infinities without melting. Then comes the paradoxes. Take Hilbert's Hotel, a hotel with infinite rooms, all occupied, but still able to check in new guests. It's impossible in real life, but mathematically sound. Your mind screams, "Wait, what?" Physicists are wrestling with infinity too. When dealing with black holes or the Big Bang, equations often spit out infinities, which usually signals that our theories are incomplete or breaking down. Some cosmologists think infinity may be just an approximation. The universe might be finite, but unimaginably huge. Others say infinity could be real, lurking just beyond our observational horizon. Bottom line, infinity is an abstract beast, too wild for your neurons to tame. Our brains evolved to survive on a planet with finite resources, not to contemplate endlessness. So next time you think about infinity, remember, your mind can't truly handle it, but that won't stop the universe from stretching on forever. As we've journeyed through these cosmic secrets, from black holes that could erase you from history, to rogue planets silently stalking the void, to the fiery fate awaiting Earth, and the mind-bending concept of infinity itself, one thing becomes crystal clear. The universe is far stranger, more mysterious, and more awe-inspiring than we could ever fully grasp. We are stardust forged in explosions, living on a fragile world, circling a star that will one day consume it. Our reality might be a hologram. Time can stop in ways that twist our understanding, and somewhere out there, watchers from the past might be observing us without our knowing. Every secret we uncover opens doors to even deeper mysteries, reminding us how tiny and fleeting we are, yet also how incredibly lucky to witness this grand cosmic show. So as you look up at the night sky, remember, we are explorers on the edge of understanding, peering into the infinite with curiosity, wonder, and maybe a bit of cosmic humor. Because if the universe teaches us anything, it's that the truth is often stranger and far more exciting than fiction. And the greatest secret? The universe is still keeping most of its mysteries close, daring us to keep searching, questioning, and dreaming. The cosmos is calling. Are you ready to answer?